All right, let's have a look at this first question. I haven't seen this question before, so I don't know. Can anyone tell me if you've already seen it? If you've seen it, if you haven't seen it, we can solve it together. If you have seen it, you can write up. Oh, you want access to the overleaf first. Let me just draw this diagram, and then we can look at the overleaf. So it's a rectangle. Yeah, I'll show you where I'll put it. So you have a rectangle A, B, C, D. AB equals CD equals 1. Ah, it's a it's a rectangle where these lengths are 1, yeah? And these are 2, okay? So it's not just any rectangle, you know exactly which rectangle it is. Let M be the midpoint of AD. I feel like this is the first question like every year. Something like this. Point P lies on the opposite side of line MB to A. Point P lies on the opposite side of line MB. So this is line MB, yeah? The point P lies on the opposite side of MB to A, such that the triangle MBP is equilateral. So it's like that, yeah? And by the way, drawing this diagram is part of the problem, so I'm kind of giving away the problem a little bit here. Find the value of angle PCB, yeah? So find the value of this angle, yeah? Okay, so before I transport back to the whiteboard, let me show you where the homework gets done. So here, what I've done here, so that's the file, right? So I'm paying for it so you can all share this for free, yeah? And all you have to do, okay, what the, yeah, the lengths. Oh, why is it, that's not good. Oh, here we go. See, share, link sharing, yeah? So I just copied this link and I put it in, is it notes and resources? It's in playlist. See, I think playlist is only visible to people who are at our school. That's the homework for term 3, I believe. Yeah? Okay. So I don't think I gave you that last time. Yes, the drawing is way out of proportion. Okay, so let me redraw this. I have a super to proportion drawing. Okay. There's actually a lot of ways we could do this problem. I think some of the ways will save me some explanations later. I might try to show you, but you have to listen to some of those ways with an open mind. I think it's also more likely you'll listen to those alternative methods if you've already solved the problem for some reason, whereas you'd think people would be more open to ideas when they couldn't solve the problem. Okay. This is B, this is A, this is C, this is D. Are we missing anything? This is P. Yeah, so basically, so the P could have been here, right? But it's not. It's the opposite side of to A. It's below the line instead of above the line. Jojo solved wrong. This is an equilateral triangle. Yeah. Yeah, I mean, when someone like the way this class works, if someone solves a problem, I really assume like everyone solves a problem. You know what I'm saying? Like we don't cater to the bottom, but we follow the lead of the strongest student. You know, whoever that may be, and hopefully it's constantly changing because everyone's trying hard. Um. Okay, what are we asked to find? The angle of
CPB.
CPB, is that right?
Yeah. Just draw a line.
Here, yeah. That angle.
Why is it that angle? What?
Oh, is it not that
CPB.
angle? CPB. That angle. Paying attention, Martin.
Oh.
Just can't scam you anymore.
I was gonna ask the question.
Is it PCB?
Oh.
Maybe I'm being scammed.
Oh yeah, I do that. I do that. I was just testing up,
PCB.
sir. Just drawing. I was just testing, sir.
Huh. PCB. There's neither of those angles. It was in fact this angle. Yeah, so I think, I mean, all those angles can be found. I mean, it's like you could just find all the angles if you wanted to.
So why did you draw the diagram so small? Like your writing is so thick now.
Hmm. Yeah, so maybe showing how to do this problem could be a substitute for some of the theory. I'll actually show you some more playlist resources. It's pretty good.
Cool. Can I get paper?
Yes. Okay, PCB is less than 60. Why is that? Daniel says PCB is less than 60.
Is it? Is to draw a really good diagram and get a good track. It's or a pencil.
Yes.
Oh.
Wait, why is it less than 60? Because it's, so those angles are 60. Yeah, I don't want to spoil this, but this is pretty easy, right? I mean, just
This angle change.
I mean, I think so. Yeah, just there's some obvious angles here.
And then and then it's 45 and 45.
Yes.
And then that's 45 and that's 50.
What MBC is 45, yeah?
Yeah. And then therefore CBP is 15.
CBP is 15?
Yeah.
Oh. Okay.
You can get the DMP is 75. Yeah.
Yes. Because this is 60, and this is exterior angle, right? It's 15 plus 60. Yeah. Hmm. What else?
DMP is also 75.
Mm-hmm.
So how do we get the
I think-
75? And in the
Yeah.
Yeah, which 75?
the one in the equilateral triangle.
You can
That
do
one. Oh, because
alternate angles.
this angle's 60, right?
Uh,
And that angle's 15, yeah?
uh,
And so that means this angle is the sum of those two. Because it's exterior angle, see? Because they both add up to 180 with this angle, right? They must be equal.
yeah.
Okay, carry on, Rihanna.
Wait, I didn't really try that.
Uh,
Then angle M and then that point between like the point where C and U.
Here,
Yeah.
like X.
That the MXC would be 95.
This is 95, huh?
Also look at
Isn't it 1 and 5?
Oh yeah.
Hmm. Not betting Martin's life on that one.
I can never see.
Okay, 105, and then what now?
Then you can find out ABC by angle sum. Oh wait, no, you can't. Wait.
So you got this angle here is 75, yeah?
Mm-hmm. Oh,
Hmm?
the chat.
The chat. Hmm. Hmm. Drawing a line. Which line? 75. What line are you talking about? MC equals MP. MC equals MP. What is that? Ah, good observation. So MC, yeah, is equal to MB, right?
Yeah.
Which is equal to MP.
Oh, that's expensive.
Oh,
So that means you can find out this angle here, right?
Oh,
Oh, and thank you, Nathan, for not spoiling. I think you probably solved this question already, haven't you? Maybe you're typing it up in the overleaf as we speak. Why is so much lag? What's going on? Hit lag. Alright. Can you see that solves the problem? So, what?
or
Okay, so it's isosceles, you see that?
yeah,
This angle is 45, yeah?
yeah.
And so that angle is 45.
Okay, so which angle's 25?
The purple angles.
it's isosceles. It's isosceles.
Yeah, that's 45.
Yeah.
And then that one's.
That one's also 45.
And then you know the other angles in the triangle, so you know the last angle, right?
Oh, I see it now. I see it.
Yeah, so
Yeah, I get
that's
it.
a good problem solving. So actually, like, it's kind of weird. So like, if you can't solve the problem, right, then you basically like leave all your work intact and submit that. Does that make sense? But if you can solve the problem, then what you're kind of doing is like you're throwing away like the drafts, you know,
Mm.
and you're just giving people the masterpiece at the end. It's a little bit weird, but so for example, if we were to write this problem up, okay, what would we do? We'd be like, okay, well, it's 1 across and 2, so it's like a rectangle like that, right? And then we might draw it a bit better so that it's even easier to see the conclusion, you know? Because this is meant to be isosceles. Like that. Ooh, internet. Let's see. I could switch to my backup internet. Where is it? Okay, so that's weird. I'm drawing the 68-degree angle almost at or horizontally. That's more like it's 45 there, so it's like a bit more than 90, right? Like that. You know? And the question asks you for this angle, right? And then we know that basically these lines are all equal, you know? And we know this is 45. This is 45. And then we might think about the fastest way to get that other angle there, right? Or any angle that lets you conclude. Oh, actually, hold on. Hold on. Wait a minute.
But then
That's not quite right.
Have to zero.
No, it's not quite. The other angle isn't 45. Hold on. The other angle is 45 plus dot, right?
Oh yeah, and then it still works, right?
Yeah, so
So you get 7 plus 2.
So see, that's why writing it up makes it more clear, right? So then, for example, like we could find this angle here. Like we basically found it. It's 180 minus 45, which is 135. Yeah. Yeah. And then we know in that triangle, 45 plus dot times 2 plus. Wait, something seems wrong.
So the same way as we did it, except instead of writing MPC equals 45, you write it's 45 plus dot. And then like you still know that the XC is like 75. So you just add 75, 45, 2 dot, and you get 60 equals 2 dot, then dot equals 30. Right?
Yeah, so wait, which one did you say? Which triangle?
You have to get the degrees of the tiny triangle. The point isn't labeled, but it's C in the point.
But surely we can. Wait, we know this is like 60. Oh, sorry. This is why am I writing 135 here? It's 135 minus 60 minus 45, right?
No.
Huh?
That isn't isn't angle DME.
Like this is 60, yeah?
Yeah.
This is 45.
Yeah.
This is 45, yeah? That's 150, so this is 30, right?
Yeah.
And if that's 30, then you get 45 plus dot times 2, which is 90 plus 2 dot, yeah? Is 150. So then 2 dots is 60 and dot is 30, yeah?
Wait,
Okay.
so it can't be 30, right? Because then you have one of. Oh, never mind. Wait, no. Oh, well, never mind.
Okay, so it's a very neat solution. Okay, how would we write this up? Okay, so actually I have the benefit of taking a screenshot. I have a screenshot here, yeah?
Right, and that's going to do.
So I could just put it here.
Oh.
I could literally just save this as in the 2022 NZMO1 Q1 diagram, yeah? Okay, I go to,
Wait, you can upload drawing?
yeah. So let's see. Actually, I'm only doing the rough thing. Like you have to fine tune it yourself, yeah, because the fine tuning takes ages, and it's not really it's not really instructive. It's obvious what to do. It just takes a while. So I'm gonna just give you the bare minimum here. I upload the picture. Yeah, right.
Got the solution.
Diagram. See. And what you can do is actually this thing helps you with the commands because if you just remember a part of the command, it help if it what do you call it? It auto writes it.
Mm-hmm.
So I go to main, yeah. So hopefully someone, when you're doing this, someone types the problem, yeah? A B equals CD equals 1. Yeah, keep typing the problem. Maybe Rihanna can do this. How about,
Until when I get home, I don't have my laptop.
yeah, how about this? So we can, this is our joint solution, okay? And then I'll write the rough sketch. Oh, see, Daniel's writing his proof, see? Yeah, something wrong with the proof environment. It doesn't have it doesn't have the same features it used to. Okay, so now we do a begin proof. Okay, and then we go include graphics. So this, I mean, aside from putting maths in dollar signs, there's the occasional command that lets you do things, but if you don't know what they are, you can just Google, right? It's actually really easy. And once you do it enough, like the same ones will come up again and again, so you won't have to do it too much. So include graphics is what allows me to do the picture. And this program is nice enough that if I start typing in 2022, okay, maybe it's lagging. It'll just give me the name of the closest thing, yeah? Okay. So then that's the diagram, right? So sometimes if the diagram is not completely obvious, like for example, the point P, it wasn't specified whether it was above A or not or something, or like it wasn't specified that like it doesn't specify. Okay, it sort of specifies A, B, C, D is a triangle, rectangle, but you don't know if it goes clockwise or anti-clockwise, right? But these kind of things are like they're not very important, right? So one kind of way to kind of get around these things. This is something I usually don't tell young people with. So sometimes I just whatever. So it's where log diagram is shown, yeah. So even though it says ABCD is a rectangle, you don't know which way it's going, right? But it doesn't matter, you know. So like the way the diagram's drawn has not lost you any generality. That's what this means, okay? And then you have, so this is without loss of generality. And then our solution, we can even refer to the diagram, right? So it basically involves angle AMB, yeah? So you want your solution when you write it, you want it to be in like short logical statements, like sentences, yeah? So for example, the first statement might be angle AMB equals 45, yeah? Okay, and what's the reason, you know? Yeah, so then you realize these have to be equal sides, yeah? So you can put then you might consider taking it a step back, right? So you'd be like, okay, you could start the proof like this. So AM equals 1, yeah? M is midpoint. Okay, it's lagging ridiculously. Jeez. Okay. So triangle AMB is right isosceles, yeah? Because AB equals 1 is given, right? Yeah. So I'm just gonna start it off and introduce you some symbols, and you gotta finish it off, yeah? Yeah, so at the moment, so Finn is pointing out, so if you look at the actual diagram, um, if you actually look at the diagram, it's really huge. Maybe that's why it's lagging. Let me diagram uploads. Where is it? Okay, but that's what like the square bracket parameters are for. They can adjust the size of the diagram and stuff like that. So hopefully you can do that. But basically, at the moment, it's a bit too big. See, you know. Well, that's the beautiful thing about this electronic document. You know, you don't have to keep writing it again and again. You just delete it. Okay, so yeah, someone's fixing it right now. Okay, and then you could be like, okay, therefore, angle, what was the angle? AMB, yeah? So the command for angle, would you believe, is angle? AMB equals 45, and if you want a degree symbol, it's circ. Okay.
Oh.
That makes sense?
Why there's so many boxes as well?
Huh?
The brackets don't make sense.
Which brackets?
They hold the brackets.
What are you talking about?
What box brackets? Round brackets.
Yeah.
Brackets with dent.
Round brackets. Oh, okay. So anything outside the dollar sign, it will just be whatever you're typing, yeah? Anything inside the dollar signs could have special meaning. So here, anytime it has a special command, it has a slash and then the command, yeah?
Oh.
Okay, so that's pretty simple, right? And then anytime, and this is obvious, like if you do, this is how to do powers, right?
Oh.
So, and then the only other thing is the curly brackets, they're like brackets that don't display. They're just there for inputting parameters into commands.
Oh.
So like this is like 45 to the power of something, right? And I want to say what that something is. Actually, I could even omit the brackets and it'd be fine because it's just one command, right? But if it was like a whole bunch of stuff and I want it all in the power, then I would use the brackets to say that's all in the power, yeah? Okay. Okay, and then okay, and then yeah. So there's symbols that give you line breaks and stuff, but in LaTeX, try not to use the line breaks because it's kind of designed to just flow. So like, I got line breaks here by just making lines between them, yeah? So these are kind of more natural line breaks. Um, oh, the diagram got smaller. Thanks. Okay, so then, yeah, I mean, in the principle of LaTeX is you can make the page look however you want, right? So in principle, any element of the page can be modified, and it's like it's the professional author's first choice for writing, unless like you're just super noob at stuff. So then you do Word, okay? But this is meant to be the professional typesetters program. Okay, so you can make it pretty later. This is not the prettiness is not the point right now. The existence of stuff is the point right now. So okay, and then you can continue the argument. Therefore, this angle is 60, this angle is that. And I think on your first time writing proofs and stuff, you should try to include all the steps. You shouldn't skip steps that you think are obvious. Yeah? Because a lot of the time something's obvious because it's already in your head, right? It might not be obvious to someone who hasn't it's not in their head. You know what I mean? And sometimes you don't even know who's marking this. Like people sometimes when they mark this, they don't even know what the problem is. They're just reading the solution. So if it looks the same as the solution, they give it mark. But if you make them think about it, that's when they're going to be annoyed, right? Because in some sense they're going to have to solve the problem themselves. So if you make it really easy for people to check it's correct, um, that's yeah. And unfortunately, the proof is not the place to impress people with your amazing logical deductive prowess. Yeah, like it's not to impress people with how you solve the problem. It's only to impress them with the elegance of the solution. That makes sense. Like the rough working and the other stuff where you don't solve the problem, that's when it's like the role you make a video and tell them how hard it was so it's solved, or we talk about it in class, or you write a book about it. Yeah, those are places where you can tell people how you came up with the idea and stuff. But the proof itself is it's really very cold and straight to business. Yeah,
Okay.
yeah. So I've been abusing this a little bit in my writing um because I'm kind of always trying to teach and at the same time, but hopefully you understand what I'm saying. Do you understand what I'm saying? That's the poll. Okay, and this proof can be this is R K N. So this is me and Rihanna, okay?
What about the
Huh? Oh, they're writing their own proofs. See? It's just that you started all the angles, so I didn't want to take full credit for it. Actually, hold on. Yeah, I mean, it was also Daniel's idea, but he's writing his own proof, so. Yeah, so this kind of thing, the only thing the guy said to me, like the New Zealand guy, was like, work on it on your own, you know? So, but I think it's okay if you just write up your solutions on your own, at least until you feel more confident with doing them. But no matter what you do, the amount of time you spend on it will be sort of what ultimately allows you to solve the problems. Okay, so I had this class, you know, very first class I taught when I met Haiping, people who got highest scores in AIMO, the people who did the most homework. Yeah, clearly spent the most time on it. Out of the 10 problems, they couldn't even solve like 4, but they could get a prize on the AIMO, right? But then the next person could only solve 2, and then exactly how much effort people put in. It was exactly their rank in the class. It was like there was no discrepancy. Okay, person put the most effort got the highest score, 34 out of 35. Then it was 32 out of 35. Yeah. And then we actually had last year, the first time we actually had year sevens in the class last year. Actually, the homework correlation was again very strong, and it wasn't all year sevens, but it was like I don't know, quite a few students, and half of them made camp. Yeah. So the effort really matters. But making camp isn't necessarily great. I mean, it's a bit overrated. Obviously, everything is either overrated or underrated. If something's good, it's overrated. If something's bad, it's underrated. You know, there's ups and downs to everything.